Hi
everyone.
Hi, the rest of the class who's not here. Good.
This is what you use for video.
Yeah, this is what I use for videos.
How much was the camera?
$70, not that it matters.
Cheapskate.
My money, not school budget.
Fair enough then.
Alright, so today we're going to look at factorising, taking it through from simple factorising through to difference of perfect squares and perfect square expansion. Starting off nice and simply, how to factorise that. Well, removing a common factor, you know already. What's the highest common factor there? 3x. We can take the x as well, leaving in there x take 7. Beautiful. Factorised nicely.
Guys, paying attention. Notebooks out, taking notes.
Yes, notebooks out, taking notes.
As you would in a normal lesson.
Thank you.
Which we never do.
You know what I mean. Now, here, that is worryingly similar to that one down there. But it's not quite the same. Fully factorising this one, we could go with a slightly different trick. So 3x squared, take 21x, that's as far as we can go. What about this one down here?
Question.
Yes.
Can you take out 6 out of the 27?
Which way?
Oh, for this one here?
Yeah.
No. Actually, I apologise, that's the wrong question. Just pretend that x isn't there.
So how am I going to do it?
Alright, so how do you factorise that?
3x take
Yeah, good. If you're down, take out a common factor, see what happens. 3x squared take 9.
which leaves us with 3x take 3x plus 3.
Good. 3, and then I'll write it in next step, x squared take 3 squared. You wouldn't normally write that step, but when you get one thing squared, subtract another thing squared, we can use our difference of perfect squares expansion, which is a plus b, a take b. So this would then expand out or factorise out to be 3x plus 3, x take 3, or x take 3. Do you remember that from year 9?
Yep.
Yes.
No. So no, that's fine. Now, this difference of perfect squares comes up quite often, and quite often when it comes up, it's disguised. And it can be disguised a couple of different ways. It can be disguised like this, where it's not immediately obvious there are 2 squared terms separated by a minus. And it can come up like this, where it seems very obvious there are not 2 squared terms separated by a minus. But both of these we can factorise by using this difference of perfect squares idea. So, this one here we can think of as x plus 2 squared take 4 squared, where this one here is our a and that 4 is the b. So the two things that factorises out to become x plus 2 plus 4, x plus 2 minus 4. What we're saying there is that's really a plus b, a take b. And then we can simplify it a step further by collecting like terms within each bracket. So within this bracket, this will become x plus 6 and x take 2. Now, if you wanted to double check this, what you could do is expand out this upper bracket here, collect like terms, expand out this, collect like terms, and the expansion of both should be the same. So we can factorise items like this when it's not immediately obvious they're really 2 things squared with a subtraction between. Last one over here, x squared takes 7. Now 7 is clearly not a squared number. It's one of these, is not a nice one like 9 or 16 or 64, etc. But we can still think of it as a squared number by thinking that 7 is really the same as root 7 squared. So really this is the same as x squared take root 7 squared, which leads us to the factorisation of x plus root 7, x take root 7. Alright, and I will expand that out to check, just to convince you it's true. I'll give you a second for notes.
We should do this like more in the videos, like give us time
No, but you just pause.
No, because you pause it. Because watch the length of this video. By the time I've gone through something that will take me 4 or 5 minutes in a video, this video will have gone for 15.
How bored do you reckon like the people that are watching this right now are
pretty bored.
But now they're
Or they're like,
this
wait,
is
I can
my
press the
voice.
fast forward, or I can make it play at double speed so everyone sounds like chipmunks, and it's not as bad.
Which program are you using to record the?
Bandicam, huh? Watch a triple speed, double speed, yeah.
1/3 the amount of distribution break.
Have you tried tiny tape?
Yeah. Nah, man.
So, and then how do you insert your videos?
I'm take dodgy because
The
it's still
Basecam videos into your.
It brings up a webcam picture automatically, and I can choose which corner to hide it.
Oh, you switch it up like each time. You do that with different parts.
I could if I wanted to, but the problem is I quite often write there, so I wouldn't want to put it there.
Do you do it with tiny tape?
I'm confused. So you're filming the screen,
And
Yes.
the camera's
and the
going-
camera will be that little box in the top corner.
Yes.
Basically,
So it'll be really hard for the people to see what you're pointing at. Because
No.
you'll be little.
Yeah.
You're filming the screen and the screen's on there.
Yes.
So it's like
So
double.
it's two screens.
it's screenception.
So you're in one of the screens.
Yes.
Right.
Basically, easy.
And the angle will be bad because I probably set the webcam so it might actually just be viewing the ceiling. Who knows?
So do we expand out here now?
Yeah. So what I'm going to do, you wouldn't normally, but just to check that we've got it right, we're going to
So
expand.
that is the answer.
That's the answer. That's it factorized. But I'm just going to run a check to see that it expands out back to our original. So our expand should be x times x is x squared. So far, so good. X times minus root 7 is minus x lots of root 7. Root 7 times x is plus x lots of root 7. And then plus root 7 times minus root 7 is just minus 7. Collecting like terms, these go, because they're same but with opposite sign, leaves us with x squared take 7. So that there is the factorized version of that.
I say that all the time.
Huh? Do I repeat that sentence quite often?
No.
No.
Oh, I'm just going to go. Alright.
Yeah, not paying attention. Way too.
There's another form of factorization called by grouping. So I'll give you a second to copy down factorizing by grouping and then these two examples.
Who actually comes up with all these names for this?
By grouping, actually by grouping makes quite a lot of sense. And you'll see why in a second when we use it to factorize. Difference of perfect squares.
I remember that.
Difference of perfect squares makes some sense as well. What doesn't make sense is things like hashtag or the cross method or
It's just something you remember.
or hashtag is really called tic-tac-toe method on the internet, but
Oh.
That's too long.
it is.
That's not as funny.
No.
And yeah, it's like in maths we use hashtags. Tweet that.
Hashtags.
Blackjack. Whatever. Underscore.
Yeah.
Alright, good to go?
Underscore.
Follow me on Vine.
Yeah, follow Jarman on Vine. Yeah, he does.
Good on him.
He hasn't posted any videos, and how many followers do you have? Like 20 or something.
Yeah.
I'm about to reach 1,000 views.
On YouTube.
I know.
Oh.
That's
Cumulatively for all the
You should
videos.
have a celebration.
This might just bump it over.
You should have a celebration video where you do more maths.
Yeah, we should.
less maths.
That
That would be a celebration.
Alright, so here,
But it got taken down copyright.
we will look at Fermat's last theorem, perhaps next lesson, which is one of the hardest problems in maths. Alright, here, factorizing by grouping works by recognizing that we might have two pairs of terms, and we're going to factorize them separately, essentially just hoping it will work. And when it works, it becomes very obvious. But here, if we consider it in halves, what's a common factor in this first half?
X.
Good. So we take out x, and that leaves us with x take a. What's a common factor in our second half? 4. And what we want to happen is for us to end up in a bracketed term that's the same as the first one. So what I'd really like in here is an x take a. What would I have to take out for that to work?
4.
Negative 4. Because if I take out the negative 4, it becomes a positive x, and that sign flips to become a negative a. So
Positive.
negative a. Because I take out a negative 4 from that, negative 4 times positive, negative a becomes positive 4.
Yeah.
Yeah.
I
So
know which
And
one
then
you're
do
talking
you
about.
put the bracket x take 4 x take?
good. X take 4, x take a.
This is like my factorizing method.
Good. Yes. So one factorizing method is called splitting the x. and works on factorising by grouping. So what we've done is we've recognised that there is a common factor here of x take a. See how x take a is a common factor. So we've removed it, and what's left is x take 4.
I don't get how you can use like this in group.
Well,
Because math is equal.
all right. You're right. I haven't done it the right way around, perhaps. If we have, I'll write again, x take a minus 4 lots of x take a. What I can think of is, imagine that there is our capital Y. And we could take out a capital Y, right? So we could remove capital Y, and what would be left would be x take 4. Because if you multiply that Y back in, it becomes there, and you multiply that Y in there, it comes there. And really, Y is the same as x take a. And that's there. I've just written it the wrong way around, which must have confused you. But what we're doing is taking out that as a common factor, and then what remains goes in the other bracket.
This is going to be really good for you.
You probably got to cover selection or something like that.
No.
Alright, so highest common factor from the left. Second example.
3x. And then we want negative 7.
Mr. Jared, what do we take out of here? So we could end up with the one of them.
Oh no, where this. Wait, what are we trying to add? X take away 2.
We'd really like an x take away 2 here.
Sure.
What can we take out of that and make sure we get one?
Well, the common factor would be, yeah, negative 7, because then when you times negative 7 by negative 2, it becomes positive 14. But what happens to the A?
Yeah, where's the A?
Good.
Ladies and gentlemen,
Good point.
pausing.
Good
2A.
Pausing.
Good.
Correct.
2A.
I think we should all just give Jared a clap.
Yeah, well done, Jared. Thank you. Correct. And how do we continue?
Alright, now we want to add.
Got no Jared, have you now?
Joe, you can help him.
No, well, we want to have the 2x take away 2a's. We want to, that becomes 1.
Yep.
And
What's
then, so
left?
that's the y. I was getting
Good.
there.
That's the Y.
3x take away 7 is the f.
Is what's left once we've taken them out.
Mm.
And you're done. It's factorised.
Oh, alright.
Well
I thought it was hard.
Good job.
Alright.
Yeah, you say that now, but on the test. The next test.
One last thing that you should just sort of know by heart and be able to flick backwards and forwards between. I know we're not factorising here, but expansion. That's a squared plus 2ab plus b squared. Please don't forget that one.
And go kill kittens.
Middle one.
Why is that there?
Yeah, bro, pay attention.
If you wrote this out twice
Stop going stuff around the classroom.
and used FOIL, or the other way to think of it, did you do the box method for multiplying?
No.
Oh,
He's also
No.
right.
Box method for multiplying looks like this, where if you have a plus b, a plus b. If you're going to work out the total area of that box, you go a times a is a squared to that portion, ab there, ba there. Yeah, a Punnett square.
So, what is the percentage that the child has had trait A?
This Mervo,
It's 76%.
Is this
You should know that way.
that thing masquerading
You
as
should know
science?
answer this.
Yeah, it's not.
Come on, answer.
What is the
How many
chances of
boxes
the child
got
having a
A's
trait
in
Yeah,
of
what's
A?
the genotype and the phenotype?
No idea what you're talking about.
Sure.
Well, I do.
Just
Genetics, I know.
Isn't one way to
It's got a
a plus b squared is to have
Are these science that you do?
what I do is I don't not expand it,
That's
go
so easy.
times the first term by the square it by 2
Yeah. Square
Then you add them both together,
Yeah. Or you
and then times by 2,
multiply them together times by 2.
and then square the last one.
Yeah, that works well.
Does that work for like 3, or is that a different? You gotta add an extra one.
No, it works. It works. Oh, for 3. No, you have to watching it. You'd have to do it longhand by 3.
Yeah.
All right. For remainder of lesson, and for those watching at home, can you please do those questions there? Read it carefully because I've let you skip quite a few, so you don't have to do them all. For example, we're jumping in straight in at question 8. Thank you very much. Good luck.
Well done. You watched the video.